I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and hit the like and subscribe button. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale circulating over the North Dateline region, producing seas in the 16-foot range, something like that. Not really doing anything, maybe producing some limited swell, we'll call it wind swell, pushing towards the Hawaiian Islands, but no obvious longer period pure swell generation potential is occurring right now. Looking at current conditions in Half Moon Bay, Northern California, buoy 46012, looking at all the energy hitting that buoy, anywhere from up to 30.3 second period energy, which there is none, which is very, very long and powerful swell energy, the whole way down to 5 second period energy, which is pure wind swell. We see a little bump here somewhere around the 19 second range. That is small southern hemi swell pushing to the north. Yes, southern hemi swell almost at Thanksgiving. And then a mixture of just small background energy, mostly wind swell in the 10 second period range, and not particularly interesting. Taking all this, putting it together, primary swell calculated at 2.9 feet at 9.4 seconds. That's about right. The bump somewhere right around in there. 2.7 foot surf, we'll call it waist high, something like that. And then some background energy, 1.5 feet at 13.8 seconds from the south. But again, small, 2.1 feet, something like that. And then looking at Southern California, Point Loma buoy, 191. This is a high-res CDEP buoy, updates every half hour. Little bump of energy, there's that southern hemi swell, 20-second period, with a mixture of other wind swell components in the water. Primary swell, 2.2 feet at 12 seconds from the west, 262 degrees. Surf height, maybe 2.5 feet, something like that. And then the background swell, the southern hemi swell, 0.9 feet at 19.2 seconds from 185 degrees. And that's 2-foot surf, something like that. So nothing particularly interesting just yet. And then finally, the North Shore of Oahu, Waimea Bay Buoy 106, again, high-res CDEP buoy. You can see the bump here. There is swell coming from the northwest, hitting the islands, building somewhere in the 15 to 16 second period range. In fact, primary swell, 2.1 feet at 16.1 seconds. Surf from primary swell, 3.4 feet. It's probably a little bit bigger than that. That's actually Hawaiian. Now, double that, I don't know that it's a foot or two overhead, but it's maybe head high, something like that. So definitely some rideable surf with some northeast wind swell in the mix as well. So we'll start looking at jet stream level winds over the North Pacific Ocean. It is deep in the fall, so our primary focus is the North Pacific. The jet stream kind of fragmented, pushing off Japan. Japan's right there. Kuril Islands, Kamchatka, Aleutian Islands, Hawaii down here, and U.S. mainland here, California, Pacific Northwest. The jet split, pushing off Japan. That does not do a whole lot to support gale formation. You want a consolidated jet, just like what it's doing as the jet approaches the dateline, okay? And you want this trough, this falling to the south thing. That's what we're looking for, because that helps support a counterclockwise flow aloft and down to the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. That is, they're getting traction on the ocean surface. As those seas radiate away from the fetch area, they turn into swell. They get groomed out when the swell hits your beach. That turns into surf. All right, so we have a trough supportive of gale development here over the dateline region, and then the jet pushes towards the U.S. West Coast, but kind of splits, half it going down here, half it up there. When you get that split pattern, you end up with high pressure. And that's pretty much where we're at. High pressure over the Great Basin, generating strong offshore winds in the Pacific Northwest and a lighter offshore flow, more or less relative to California. That's kind of a nice situation in that it's high and dry. You have offshore winds. Any swell generation will occur out here. But, of course, we are in a drought. We do need weather and rain and snow, and so this is not conducive to that. The good news is that pattern shift is coming. All right, as we move into Monday, the trough continues off to the east and then possibly deepens a little bit as we get into Tuesday and Wednesday. You see that right there with, what is that, 150, the light, almost 160 knot winds pushing down here. That helps really get that counterclockwise flow going, and that's exactly what we want. So it looks like there's potential for a gale as we get into Tuesday, Wednesday sort of thing in the Gulf of Alaska. The gale looks like it's starting to get, or the trough gets really pinched. That does not do a whole lot for gale development as we get into Thursday. Notice the big ridge here over the U.S. West Coast. Again, high pressure and dryness, if anything. But then as we get into Friday, things start changing. That trough gets cut off. Notice a new trough building off the Kuril Islands. Ridge over the dateline. Something starts developing in the Gulf, trying to get going. You see sort of this backdoor troughy thing. That's the classic way to get precipitation during La Nina years, because typically you have high pressure sitting right here. So the jet rides up and over and then pushes down the coast, dragging a lot of cold air with it. So it's not wet, heavy snow. It tends to be lighter, very powdery type snow, which is a good thing. But we could use more of the wet variety. Anyway, we're 180 hours out. We're into Sunday. It's actually Sunday night, the 27th of November, and the trough pushing down the U.S. West Coast with likely, or hopefully, a deeper trough coming behind that. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, weak low pressure. What is that, about a 980 millibar low or 984 millibar low? That's pretty ineffectual, generating some 20, 25, almost 30 knot winds. Again, that's enough for wind swell maybe pushing towards Hawaii, but that's about it. Moving out in time, though, things start getting interesting. Notice a little bit of tropical low pressure, some other low pressure here. High pressure over the North Dateline region, things trapped below it, and there we go. That tropical low pressure is to start building on Tuesday with 40 knot northwest, north winds aimed at Hawaii and west winds aimed at the U.S. West Coast, lifting northeast quickly on Tuesday night, 50 knot winds aimed at Hawaii and the U.S. West Coast, building to 55 knots late Tuesday night, and Wednesday, the storm, that's 50 knot winds, that puts it in storm category, pushing into the northeastern Gulf of Alaska with strong high pressure behind that, 1040 millibar high. The difference in pressure between the low here and the high here creates a gradient, a tightening of these isobars, generating more wind spraying off to the southeast. And also notice this, some sort of fetch on the south end of this high, targeting Hawaii from sort of a north-northeast direction. Also notice as we get into Thursday, more low pressure building, kind of a interesting dynamic situation. Cutoff low developing aimed at Hawaii on Friday. We'll just get right to Friday morning. 40 knot winds aimed at the Hawaiian Islands. Not sure that the wind pattern locally is going to be that great. Gale off the Kamchatka and the North Kuril Islands with 50 knot winds aimed off to the southeast, so maybe some long-distance swell for the U.S. West Coast, for Hawaii, and very long distance for the U.S. West Coast, lifting northeast and kind of gone. High pressure trying to take over as we get a week out into Sunday, and then that's the end of that. Let's go look at the effect of these winds on the ocean surface. First off, we're going to go back into time to Thursday, the 17th of November. A little gale developed here just west of the dateline, producing 26, 27. There we go. A little patch of 30-foot seas, 31.2 to be exact, at 42.75 north, 171.75 east. Right there, you can see the little plus sign. That's where the max seas are. This is the highest seas over this whole domain. Aimed pretty well at Hawaii and a pretty good long ways away from the U.S. West Coast. Pushing off to the east, made it over the dateline on Saturday. That was yesterday, the 19th of November, and then started fading north of the island. Swell from this system, that is what we saw on the Waimea Bay buoy, little tiny swell working its way in there, and also bound for the U.S. West Coast. I think it's on sometime Wednesday, something like that. Not much size, but a little something to ride. Now, looking forward, based on everything we saw in the jet and at surface level, we know something is forecast to develop in the Gulf on, what did we say, Tuesday, something like that? And there we go. The beginnings of our storm with 26 to 28 foot seas aimed at Hawaii and the U.S. West Coast, quickly building as we get into Wednesday morning, but lifting northeast with up to 38.2 foot seas aimed at the U.S. West Coast, and probably 28 foot seas sideband swell pushing down into Hawaii. Then pretty much by Thursday, Thanksgiving Day, only targeting Canada and maybe the Pacific Northwest sideband energy down into there, but still a broad area of 20 to 22 foot seas behind that, targeting both Hawaii and the U.S. West Coast. New gale activity starts developing behind that. We also know there's some sort of cutoff low thing. So there we go, developing northeast of Hawaii with 20, 22, 25 foot seas targeting the Hawaiian Islands. But again, the winds likely are going to be very Kona-like and probably be a pretty blustery mess there. Gale developing off the Kuril Islands as we get into Friday and Saturday, 33 foot seas, and then that fading out. So maybe some swell, long-distance swell for Hawaii and the U.S. West Coast. But typically on those ones that are west of the date line, at least for California and that area, very long waits between sets and kind of slow and leaves you wishing for more. Anyway, and then a week out, kind of a weak pattern behind that. Now, we mentioned when we were looking at the buoy, Point Loma buoy, Southern California, that small southern hemi swell is in the water. That is true, and it's only forecast to build some. First, a gale developed. This was Sunday a week ago, the 13th of November, off the Antarctic ice in the far southeast Pacific with seas 31 feet on Sunday the 13th, so Southern California cutoff is about 117 west. So this was on the very east end of that window or south end of the window. So this would be like a 185 to 180 degree sort of swell. That faded out, but then quickly behind it, another gale developed starting on Wednesday with 25 foot seas, something like that, and then finally got going good on Thursday into Friday, again with about 31 foot seas aimed to the northeast, and again on the hairy edge, the Southern California swell window. The net result is small southern hemi swell for Southern California starting tonight, all the way through the coming work week, and probably some degree holding through the weekend after Thanksgiving. That's a good thing. If the north swell that is expected is blocked, the southern hemi swell will certainly get into exposed breaks in Southern California. Northern California will see probably none of the southern hemi swell because all of it will be buried in northwest swell. And because these systems were too far east of the Hawaiian swell window, no swell expected for the Hawaiian Islands. And we're not even going to show it, but the forecast model looking beyond this, literally no activity for the southern hemi. It's kind of a freak thing to even have this in November, so we were reporting it, but otherwise we're pretty much done looking south for the year. The all-critical wind forecast, so high pressure over California, and it's really kind of the Great Basin type thing, the offshore flow. I was up in Oregon a couple days ago, strong blowing east winds in that area, and much more moderate down into California, but clear signs of the Great Basin high pressure. In fact, someone even commented, when are we going to get a Great Basin high pressure system? Well, we got it right about the time the comment hit, it developed. And so we're in that flow for right now. Hawaii in a trade wind flow, 15, 20 knot easterly trades. We get into Monday, pretty much the same sort of thing. Tuesday, notice a little low pressure trying to push into the Pacific Northwest. That probably will be the end of the offshore flow for the Pacific Northwest. California, sort of a northwesterly wind flow at 10 to 15 knots. Notice the storm north of Hawaii and off of California. So we get into Wednesday, sort of a more northwesterly flow. So the high pressure, the offshore flow, probably holds near shore in the mornings, but not as clean as it was. So we get into Thursday, sort of the more thing. Now notice this front here in Hawaii and the winds turning more northerly. Let's put that into motion. And then you go, here we go, Thanksgiving night, full-on Kona wind event pushing into the Hawaiian Islands. Northwest winds at, 25, almost 30 knots. And then, northeast winds into the Hawaiian Islands. And a light flow, high pressure for California. As we get into Friday, pretty much a light flow for California. Developing closed isobar low northeast of Hawaii, and the bad wind flow continues. Saturday, the winds lighten up for Hawaii, but still very much out of the north, driven by this low. It's actually a cutoff low northeast of the islands. Also notice northwest winds on Saturday picking up for California, pretty much blowing everything out. And Sunday, things moderate, but here comes your low pressure. Here comes the beginning of that backdoor trough and maybe potential for precipitation pushing south down the coast as we speak. Finally, a more normal wind pattern sets up for Hawaii. Let's go take a look at precipitation. We're focused on California here, right now, and the blue is, of course, precipitation. The expectation, high pressure in control. You need to notice fronts, the line has been this whole year, the dividing line, the Oregon-California border, and so that's in effect. A little bit of precip up north. That was on, Tuesday, Wednesday. We get into Thursday, Friday. The next system tries to set up, but it too pretty much just dissipates, can't punch a hole in high pressure. Then we get into Saturday. It tries to set up again, trying to work its way south. Theoretically gets a boost and pushes south into California on Sunday. And look at this, late Sunday night into early Monday, snow for the Siera, rain the whole way down to, we'll call that, somewhere south of Big Sur, but a little bit north of Morro Bay, that sort of thing. So looking like some potential for more precip in the Siera. Snow forecast dashboard for Squaw Valley, Palisades, Tahoe. Thing you can see it pretty much plain as day. And this goes out 10 days. The other models we were looking at only go out 7 days. You can see snow potential or accumulation potentials here. We'll just looking down. Let's see. We have 28.3 inches if you believe a model going 10 days out. Kirkwood getting 21 inches. And Mammoth considerably less, totaling maybe 8 inches. The good news is, looking at even longer range models that go out 2 weeks, 3 weeks, 4 weeks, the suggestion is this is just the start of a wet pattern coming beyond that, going out for several weeks. So, and that this has been on the model forecast starting somewhere around Sunday. It's been on for at least a week now. So, the expectation is something's going to happen. Exact details, way too early to know, but at least we're moving in the right direction. All right, let's go take a look long-term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation. These are the two oscillations. The MJO gives you kind of a 6-week look out if you know what it's going as to what might happen. Then, of course, the El Nino Southern Oscillation can give you indications out a year or two or even more. So we start by looking for signs of the active phase of the MJO. There's two flavors of the MJO, the Madden Julian Oscillation, the active phase and the inactive phase. The active phase is effectively a low pressure system. The active phase, both phases of the MJO travel around the planet, east to west on the equator. The active phase is a low pressure system when it's in control over the Pacific. It imparts energy to the jet stream, feeds the jet stream, makes it stronger. That helps promote storm development and swell development and snow production, all those good sorts of things. And also, if it's strong enough over the West Pacific, it can reverse trade winds. And what that does is take warm water that's typically piled up in the West Pacific, can start pushing it to the east, not on the surface of the ocean, and it travels under the equator the whole way across the Pacific, that ball of warm water. It's known as the Kelvin wave, and when it erupts in Ecuador and the Galapagos area, it creates a slick or a pool, an upwelling event of warm water there. If you have successive active phases of the MJO, they create successive Kelvin waves, and that can lead to significant warming in the East Equatorial Pacific. That is the hallmark of El Nino. So we're very interested in Kelvin waves in the active phase of the MJO. Inactive phase does the exact opposite. It's high pressure. It steals energy from the jet stream. The jet stream splits. You don't get precipitation. You don't get surf, or at least the potential for it decreases. And generally, if you have a dominance of the inactive phase of the MJO, which is what we've been having, you get cold water upwelling off of Ecuador, trades are enhanced, high pressure and control, and that is pretty much the signs of La Nina. Likewise, if you're getting a lot of Kelvin waves, a lot of active phases of the MJO, that's the hallmark of El Nino. All right, so we're looking for signs of the active phase of the MJO because the active phase is what brings all the good stuff for us. So this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. West Pacific here, East Pacific here, the equator right there. That is New Guinea there. We're just looking at the arrows. They are wind sensors that are on the TAO buoys. And the longer the arrow, the stronger the winds. Direction pretty much self-evident. Trades out of the east, strong over the East Pacific, strong over the Central Pacific, and according to this, strong over the West Pacific. But it is not the actual wind speeds, it's the anomaly. The difference in normal and the wind speed, average wind speed for this time of year. We see winds are a little bit stronger out of the east here. That's probably a sign of the inactive phase of the MJO. Same thing over the Central Pacific, same thing over what we call the Kelvin wave generation area. When the active phase of the MJO is over the area from the West Pacific, starting about 135 east to about 170 west, 5 degrees north and south of the equator, right in this area right here, then these trades will be reversed, and then that sets up all the good stuff. It is this area right here that we monitor most, the Kelvin wave generation area, looking for the active phase of the MJO to move over this area, to reverse the trade winds, to create Kelvin waves, to impart energy to the jet stream, and then that results in storms and precip and all the stuff that we're real interested in relative to California. So wind speed and direction over the West Equatorial Pacific is paramount to feeding the whole storm cycle, so we focus in on that a lot. This chart, 850 millibar zonal wind anomalies, that's winds up about 4,700 feet, but a pretty good proxy for what's going on down at the surface. Now this is the wind anomalies, the east-west component of the wind. The east anomalies, the blues and purples here, west anomalies, the reds and yellows here. The east anomalies, this would be the inactive phase of the MJO. The west anomalies, the active phase of the MJO. But let's get ourselves oriented here. The date line runs right up the middle of the chart, okay? So we see a big batch of easterly anomalies on the date line. The West Pacific goes to 135 east, so, and this is past what's happened. This is the future forecast right here. So if you draw a box pretty much like right here, this is where all the action is. This area only, and you can take that box the whole way up the center of the chart here, but you can see easterly anomalies for the most part have been in control. They have been for 2 years now. That's typical of La Nina, right? And now you see easterly anomalies pretty strong on the date line today and the next day, the day after that, but you get about 5 days out. Easterly anomalies start weakening. They're not gone. And the westerly anomalies, well, they're still over the maritime continent as they have been. But the suspicion is something is going to change in right after Thanksgiving, somewhere right in there. Let's go look a little bit further out. This is zonal wind anomalies from the GFS model going out 2 weeks. 925 millibar zonal wind anomalies. So that's even closer to the surface, maybe 1,000 feet up, something like that. Then let's get ourselves oriented. So there's the Galapagos right there, the equator right there. Kelvin wave there's New Guinea there. Kelvin wave generation area, 5 degrees north and south, out to about 170 west. So right in this area. So right now, we see easterly anomalies in control. We're just going to put this into motion. This is a pretty cool little chart. And also notice westerly anomalies trying to set up in the East Pacific. Put this into motion, and look, we're about getting to, where are we? Friday, November 25th. Easterly anomalies significantly fading, westerly anomalies trying to build in. Let's take it even out a little bit further. Easterly anomalies all but gone. Westerly anomalies start building on November 28th in the West Pacific. We haven't seen that for a while. And then we'll put this into motion even further. They continue. Easterly anomalies try to build back in. Let's see how this comes out. But then westerly anomalies again setting up in the far West Pacific on Saturday, December 3rd. Then finally, easterly anomalies punch a little hole in that, but you almost get the sense they're getting ready to fade again. And look at the westerly anomalies all over. In fact, I'm going to go back and roll this just backwards. Westerly anomalies over a good portion of the West Pacific, I mean, pretty much for the next 2 weeks. Something is changing. All right, so let's look at another component of the MJO, and from a different model. This is outgoing long-wave radiation, fancy words for cloud cover. The blues are areas more cloudy than normal. That is, if you have more clouds, you can't get sunlight bouncing off the ocean surface, and so you get this negative anomalies. But just consider this clouds, consider it low pressure, consider it the active phase of the MJO. And the inactive phase, high pressure, lots of sunlight reflectivity off the ocean surface, occurring in the Indian Ocean. In fact, Africa, Indian Ocean, Australia, Kelvin wave generation area right there. So the active phase of the MJO is setting up in the Kelvin wave generation area today, holding 5 days from now. This is the statistic model. Then fading some 10 days from now and 15 days from now. The dynamic model saying pretty much exactly the same thing, with maybe a week inactive phase setting up 2 weeks from now. So our active phase window appears to be about the next 10 days, something like that, week and a half. All right, let's dig deeper. Looking at those same two models, statistic model here, the dynamic model here, phase diagrams, just to drill in where the active phase is and how strong it is. The MJO active phase moves from west-east, from the Indian Ocean to the maritime continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is today, so somewhere in the very far West Pacific. Now, this is a 2-week model run. The forecast, 1, 2, 3 different tracks of where the active phase is going. And the active phase, the further it is away from this circle, the stronger it is. So pretty weak, modest at best. Forecast tracking to, the Atlantic, and very weak 2 weeks. The dynamic model suggests a little bit different picture. The active phase building, and if anything, getting pretty strong over the West and Central Pacific, about 1, 2, each dot is a day. So 1, 2, 3, 4, 5, 6, 7, 8, something like that. 8 or 9 days over the next 8 or 9 days, and then getting very weak, crashing, but retrograding back into the West Pacific 2 weeks from now. So something is afoot. Next up, the upper level model, showing areas favorable for precipitation. The greens, favorable for precipitation. The oranges and yellows, dry air, not favorable for precipitation. Consider the greens, roughly the active phase, the oranges and reds, inactive phase. And let's get ourselves oriented. This goes out 40 days, 5 days each panel. South and Central America here, New Guinea, Australia, equator right there, the date line roughly there, Kelvin wave generation area in this area. So active phase of the MJO in control today, slowly making its way across the Pacific through about mid-December, then fading out. Inactive phase percolating over in the Indian Ocean, and then pushing its way across the Pacific starting, we'll say the second week in December, and then continuing on into the end of December. Now, this is a statistic model, and if you remember from what we just looked at, the statistic model suggests the inactive phase developing. The dynamic model says none of this is going to happen, and that the active phase will in fact redevelop or remanifest itself, perhaps in the December timeframe. Well, a little bit of uncertainty, and we don't believe a model a week out, much less 40 days out, but something to consider. All right, and then another opinion, the CFS model going out a month, all right? This is the whole planet on one chart, the east-west component of the wind, so the date line running right up the middle. Kelvin wave generation area right about from 135 east, so somewhere right in here. And in the past, you can see the blues, easterly anomalies, inactive phase of the MJO in control for the most part. In fact, the dotted contours here, that's the inactive phase. The solid contour is the active phase. Notice none of them even make it into the Pacific, or they haven't in the past. They are not forecast to in the future, at least for the next 40 days. But an interesting development, one we've been talking about for weeks now, is on the very precipice of occurring now. In fact, we've made a little progress. You can see westerly anomalies have made inroads in bits and pieces since somewhere around the second week in October. Okay, right now, westerly anomalies pretty strong, trying to work into the Pacific, but the blues, easterly anomalies in control, and they're supposed to hang on for about, according to this, one more week. And then look at this, the active phase of the MJO and a big push of westerly anomalies. That's a Kelvin wave, that Kelvin wave producing westerly anomaly event, theoretically, December 3rd. And then even after that's over, at least neutral to light westerly anomalies hold to about 150 east. That's halfway through the Kelvin wave generation area. It ends right at 170, so we'll say 40% of the way through. And that's more than we've seen in 2 years. Again, another sign of perhaps the weakening of La Nina, at least from an atmospheric perspective. And then if you don't like a model that goes out 30 or 40 days, well, let's go out 3 months. And we laugh and we say that's all a joke, but you know what? This model has done an amazingly good job. Everything considered so far, we're on the precipice of something big. It's been talking about it for months now, and well, let's talk about it some more. All right, so again, the east-west component of the wind, this is the forecast up top here. Look at the dates, and this is what has happened in the past. Again, whole planet on one chart, the date line running right up the middle. The blues are easterly anomalies, the yellows and oranges, westerly anomalies, the active phase of the MJO, or if nothing else, you could say it's the El Nino La Nina indicator. All right, so you can see in the past, easterly anomalies dominating the entire Kelvin wave generation area up until about October 15th, and westerly anomalies made an incursion deeply into the Kelvin wave generation area. They are in retreat for the moment, but these are 1 week tick marks here. Well, they're actually 8 day, but you get the general idea. 8 days from now, easterly anomalies are to retreat completely to the date line, never to return again to the Kelvin wave generation area. And if anything, westerly anomalies as we get into January, taking over the entirety of the Pacific. Last week, it was not showing this signal quite as strong. This week, it's back again. And also, easterly anomalies building over the maritime continent. This is what typically happens during El Nino. You get easterly anomalies over the Indian Ocean, westerly anomalies over the Pacific. For the past 2 years, during La Nina, we've had easterly anomalies over the Pacific, westerly anomalies over the Indian Ocean. That has locked down, just promoted nothing but high pressure over the Pacific. And as of, we'll say 7 days from now, next Sunday, we're hoping to be able to report that the last of the La Nina easterly wind pattern will be done with, and that we're moving into at least a neutral ENSO regime. Now, what does that mean? That doesn't mean that La Nina is over, but the fundamentals that are holding La Nina and keeping it in place will disintegrate atmospherically, and once that happens, the ocean will follow suit, and we'll get into that in a minute. So let's overlay the MJO here. We've kind of gone off track. A weak pattern. I mean, you can see the dotted contours here are the inactive phase of the MJO, the solid contours, the active phase, and there's like no real rhyme or reason to anything. A weak MJO pattern forecast for the next 3 months, but the low pass filter, this is the high pressure, low pressure bias. And we've talked about this every week. Dateline running right up the middle. This dotted contour, mega high pressure, locking down the Pacific. Well, the second contour is supposed to fade December 15th, let's say. And then the full high pressure bias completely is to disintegrate by February 16th. It's to be out of the Kelvin wave generation area. Oh, maybe we'll say, did I say February 16th? Anyway, by about late January, that should fade. Notice the low pressure bias. This is the El Nino indicator, which has been over the Indian Ocean for 2 years now, making a major incursion, almost filling the entirety of the Kelvin wave generation area as we get deep into February, which is what this model has been suggesting. It kind of waffles and changes from week to week, but it's back to being pretty strongly in favor of the complete demise of La Nina as we get deeper into winter. All that sounds great, but there's two components to this. It's the atmosphere interacting with the ocean. And everything we've been looking at so far in this presentation has been the atmosphere. And is the atmosphere changing? And what's low and high pressure doing and all that? The hard reality is we have a giant pool of very cold water filling the entire equatorial Pacific right now. The atmosphere will change. That will help start nudging the ocean to change in a favorable direction. But is there any evidence of that occurring yet? And the short answer is probably not, but let's dig in. All right, so this is data from the TAO buoy array. Again, those buoys strung across the equator used for monitoring El Nino. This is the West Pacific here, East Pacific here. The X's are the anchor lines, or these are the anchor lines on those buoys. There's 600 to 900 miles between each buoy, so it's just a very rough guess. But the X's are sensors on those anchor lines. They record data, water temperature, and what we're trying to do is get a profile of where is the warm and cold water in the Pacific and where is it moving. Kelvin waves are a ball of warm water that move from the West Pacific to the East Pacific, driven by the active phase of the MJO. Is there any evidence of that occurring? Well, this is the actual water temperatures. The 28-degree isotherm is about where it was last week. It hasn't changed at all. The 24-degree isotherm, it's been waffling somewhere around 152 to 155 for weeks now, so no change there. The 24-degree isotherm, well, it was over at 120, something like that. It has, if anything, gone backwards, suggesting trades are increasing here. That's certainly not a Kelvin wave, but this is just mean temperatures. The anomalies, the difference from normal for this time of year, paints a different picture. Suggests very warm water in the West Pacific, 3 degrees centigrade. That's about 5.5 degrees Fahrenheit, something like that. Down 150 meters. The leading edge of it, according to this version of the model, has made significant eastward progress to 130 west. It was at 140 west the week before that, and 150 west the week before that. This suggests a Kelvin wave is already in flight, with cold temperatures here 2 degrees below normal at about, well, where is that? That's about 120 west. So that'd be south of California, and moving off to the east, getting squeezed to the surface by this supposed Kelvin wave moving off to the east. Now, we don't really believe that. Why? Well, we need to look at more data. Here is another model using totally different technology. It doesn't use the buoys, it uses satellites to somehow peer down into the ocean. It doesn't actually read the temperatures, but it infers temperature profiles based on ocean height. We'll get into that in a second. But the short of it says much, much warmer temperature. What is this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 4 to 5 degree centigrade anomalies in the West Pacific, but they're only at, what is that, about, just eyeballing, it's about 150 west. That's where it was last week. Hadn't moved at all, or maybe just a couple of degrees. And colder than, much colder water in the East Pacific, and it's not going anywhere. But this is November 14th data, and today is the 20th, so this is about a week behind. They'll probably update this on Monday or Tuesday. It updates every 5 days, and we'll see if there's any nudging or change. The main source of the data for that model we just looked at is this. This is sea level anomalies. Okay, so what's that mean? It's the height of the ocean, all right? take away the waves, take away the wind waves, take away even the tides, and is the sphere of the ocean higher or lower than normal? Well, what does that tell us? Well, we know that cold water at depth contracts, and when it contracts, it'll create a divot on the ocean surface. We know that warm water at depth expands, and that'll create a bump on the ocean surface. The more warmer, the higher the bump, the higher the temperature of the water below. So this is, okay, let's get ourselves oriented. Equator right here. This is Chile, Peru, the Galapagos right there. Central America, Mexico, Hawaii up here. Dateline right here. New Guinea there. All right, so warm water inferred by plus 15 centimeter anomalies over the West Pacific, and cold water in the East Equatorial Pacific inferred by minus 15 centimeter anomalies here, well west of the Galapagos, and the dividing line between the two somewhere around 150, something like that. But last week, I don't think we were seeing these yellows making it east of the date line like they are today. So interesting. We'll have to see here. And then putting all that together, upper ocean heat anomalies. That is, where is the warm and the cold water, and where has it been relative to the, well, West Pacific here, East Pacific here, the blues, colder waters, the reds and yellows, warmer than normal water. So, and we're going back December or November last year, cold water in the East Pacific. You can see the Kelvin wave, warm water, making one Kelvin wave made it across the Pacific. You need multiple Kelvin waves to get yourself into El Nino. We had one, then we had another upwelling event. Then we had 2 attempts at another Kelvin wave, but that resulted in only 1 weak Kelvin wave back this past summer. And then since then, it's been cold water, cold water, cold water. But the leading edge of that cold water is steadily starting to make its way off to the east. The core of the cold water, though, locked solid. So we want to see some movement in this whole mass heading off to the east, and we want to see some movement of this warmer water here making it off to the east. If you actually look here, though, you can see the leading edge of this slowly, ever so slowly moving off to the east. This is not like a Kelvin wave building. We think this is literally, we talked about the change in westerly anomalies in the atmosphere, and the change in the subtle, slight changes in the atmosphere we think are already affecting the ocean, slowly building warm water as much as it can across the Pacific, but it's slow and it's not dramatic yet. All right, so we've talked about all these changes, but at the end of the day, it's what's happening at the ocean surface that matters. Cold water at the ocean at the surface supports high pressure loft. That is, it doesn't support evaporation. You need uplifting air, moist, warm air to create low pressure systems. We're looking at sea surface temperature anomalies, differences from normal for this time of year. Peru down here, Chile there, Peru, Central America up here, Hawaii here, the equator right here. You can see it's kind of doubled up, but you get the general idea. Very cold water in a line from Ecuador over the Galapagos, extending out to about 135 or 140 west, and then colder water east of there, west of there. Now, we've been talking a lot about this south end of this region, down around 20 south, still cooler than normal temperatures, but not nearly as cold as it's been. Some softening in the temperatures in this region. And all the warm water is way to the south or north of the equator. And the official El Nino monitoring region is from 120, so right here, out to about 170, this area. And you can see nothing but cold water right now. So the atmosphere trying to do its thing, trying to get organized, but right now, cold water firmly entrenched, not seeming to be moving, and no signs of a Kelvin wave yet, though there is a general sense that some warming is trying to push from the far west Pacific. That might be suggesting that trades in general are just weaker than they've been. High pressure, weaker than it's been, both north and south of the equator, and some softening of La Nina. We say that, and we actually have some evidence to support that, but let's dig just a little bit deeper still. Now, sea surface temperature trend for the past 7 days. Last week we had warming. This week we have cooling immediately along the equator. Certainly the trade's picking up. Some sort of maybe the inactive phase of the MJO sliding out of the Pacific, and the active phase in the East Pacific, the active phase building in the West Pacific. But right now, a cooling regime where we don't really want it. Now, warming in the deep south, we had there was warming temperatures up in this region for the past several weeks. That seems to have moderated some, though warming still continues off of Chile and Peru, but just right on the equator, not a good sign, at least for the moment. And then the overall view, and we talked about this strong cooling here. Is that maybe that warm water at depth pushing east, trying to squeeze some of the cold water at depth to the surface? Maybe. Or maybe it's just the trade's blowing harder than normal for a couple of days. There's a lot of noise in all this. We're looking at we're very much down in the weeds here, but the trends are at a very broad brushstroke level picture. And right now, clearly, La Nina is still in control. The official El Nino monitoring region right in here. The Nino 1.2 region, they call it, right in here. The combination of that and the Kelvin wave generation area. So basically, we've mapped the entire equatorial Pacific into chunks, and we can use them to monitor things that are going on. The West Pacific, you can see lots of warm water here in the West Pacific. We just need some westerly anomalies blowing over this area to get a Kelvin wave going. There's massive amounts of warm water at depth, and once that gets in motion, especially if the high pressure systems are getting weaker and the trades in general are getting weaker and La Nina is sort of losing its grip, it won't take much to shut all this down. It'll take a month or two in time, but it'll change. All right, let's keep going. Sea surface temperature trend in the Nino 1.2 region. That's the area right there near Ecuador and the Galapagos. Kind of a noisy area. Temperatures today still very cold, minus 1.769 degrees below normal, right there. Trend the past couple of days falling, but temperatures have pretty much bottomed out since late September and really aren't going anywhere at the moment. The official El Nino monitoring region, the Nino 3.4 temperatures are 1.107 degrees below normal. The La Nina threshold, where you go to ENSO neutral, is half a degree below normal. It's not even on the chart. So we're still way below that, clearly in La Nina territory from an oceanic perspective. And the ocean surface, of course, is what's driving the atmosphere. That said, we know there's things going on in the West Pacific. We think we're a week away from significant changes happening in the West Pacific. The change will start there, and then it will propagate its way across the entirety of the Pacific. This will be one of the last things that will change. So we talked about softening of La Nina in the atmosphere and some evidence for that. All right, we're looking at the Southern Oscillation Index, difference in pressure between Darwin, Australia, Tahiti, Darwin in the Indian Ocean, Tahiti in the Pacific, roughly more or less on the equator. When pressure is lower in the Pacific over Tahiti, the index goes negative. When pressure is higher in the Pacific and lower over Darwin, the index goes positive. Today we're at 2.92. And you kind of look down here and you go, these are actually pretty good numbers. We've had a bunch of negative readings since November 4th. Now that is not much of a trend, but beggars can't be choosy. If you look prior to that, this was like pinned at 20 for years on end. Now, just lately, there's some softening going on. The 30-day average, you average that out and take the noise out of this. Well, we're at 7.96, but where were we a month ago? 20? So this is, at right now, you'd probably go, oh, this is your MJO active inactive phase indicator. You could probably say, okay, we're moving into the active phase of the MJO and it's driving pressures down. But based on those other models and the westerly wind anomaly pattern moving further into the West Pacific, we suspect something more than that is going on. But we look at the 90-day average, 14.49. What's it been? Well, a month ago it was 15.16, so it isn't going anywhere. You want to see all these things heading negative if you're going into El Nino or even a strong active phase. We're not seeing any of that. But the sense is, well, in fact, let's look at the graph. Maybe that'll speak to us. Here's a 30-day moving SOI graphed out. The downward spikes are the active phase or falling pressure. This is neutral right here. You want to get down below here. The upward spikes are the inactive phase of the MJO. That's high pressure building over the Pacific. Notice that since pretty much October, for almost a month now, we've been in a steadily declining pattern. You notice we had one of these April in 2021, and then the pattern was all up from there. But given that we're in a two-year La Nina, we're going to keep our eyes on this, and we're hoping, we think, as westerly anomalies build, especially starting a week from now, 6 days, 7 days from now, if that really happens, this will continue to fall, and maybe it will get somewhere near neutral. We have very modest expectations, and that's what they are for the immediate future. And then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model. All right, this is pretty much unchanged, but if anything, it's gotten better than even last week. Temperatures -1 degree, more or less, for a year now. You can see it. Come December, that's right now will be at 1 degree below normal according to this, and pretty much not really changed from what it is today. We basically have 2 or 3 more weeks to go, and then by mid-December, temperatures start creeping up. And what we've been really looking at is, well, what are the temperatures supposed to be? This is the middle of the month of January. Well, this has actually creeped up a half a degree or so, maybe even, what was down here is about 0.75. This looks like it's about 0.7 of a degree below normal come January. And now it was supposed to be mid-February and then early February, and now it's looking like by the last week of January, we'll be out of La Nina officially and into ENSO neutral territory, heading steadily up, and according to this is the raw data, moving into El Nino territory as we get into the summer. Now, this needs to be corrected. There's some biases in this, and here's the corrected version. But it's saying the same thing. Temperatures not just going to 1 degree below normal. Temperatures by mid-January at -0.65 of a degree below normal. That's an increase. And then by the end of January, maybe even the 20th of January, something like that, we're at ENSO neutral, and then moving also towards perhaps weak El Nino conditions as we get into the summer. So both these models have upgraded a little bit. All right, so let's zoom back into what's happening in the next week. Well, small southern hemi swell for Southern California. Looks like a gale building in the Gulf of Alaska with maybe some decent swell for Hawaii, but maybe bad wind conditions and some local storminess in the area. California, perhaps a decent Gulf gale swell if the gale develops as forecast on Tuesday, Wednesday, which we expect that to happen, and some swell from that with decent wind conditions. But then quickly following that, as we get later in the weekend, it looks like the weather pattern will change, the Great Basin high pressure system breaks down, and perhaps a period of storminess settling into California and the Siera, bringing rain and snow in the mountains. We'll take every bit of it we can get. And longer term, well, right now, still clearly in La Nina conditions, but the thought is that westerly anomalies, if we give it literally 1 more week, a significant pattern change is going to start setting up for the West Pacific. Westerly anomalies building into the Kelvin wave generation area and continuing for months to come. That would mean more energy imparted to the jet stream, a better storm track, more surf, all that sort of stuff. We think that transition will be happening as the surface waters in the equatorial Pacific start returning to neutral or normal come somewhere around mid to late January. And by February, we could actually be in a semi-decent position. That's a lot of ifs, a lot of hope, and a lot of betting on models, but all those models have been rock solid for months now. We don't see any reason that it's going to change, and they have more or less verified. In fact, we didn't even look at it, but the consensus model updated of all the El Nino, La Nina models, and they're all basically saying the same thing too, so we didn't need to bore you with yet more details. Anyway, things are looking very good, and we are continuing to be cautiously optimistic that the death of La Nina is imminent. All right, if you enjoyed the video, give us a thumbs up, like, and subscribe. Comments welcome. You don't understand something, give us a comment. We'll be happy to answer, and we try to do it pretty quickly. And other than that, we'll do this again next week, same time, same channel. Thanks for watching, and we'll see you then.